Hi, my name is Xiang He. I'm the Strategic Marketing Specialist for Thermo Fisher Scientific. I'm here to present a poster on the quantitative analysis of plasma-free medinefrins using ASMS with the C18 solid phase extraction assisted with ion pairing reagent. Overview. Purpose of this method is to develop and validate a fast and sensitive ASMS method to quantify plasma-free medinefrins, or we can call it PMEDs. The methods are basically two parts. One is the ion pairing solid phase extraction, and the second is the LC chromatography using the porous graphitic carbon-based column. And the results, we have developed and validated a very fast and very sensitive method for PMEDs, and we didn't observe any adverse impact on the mass spec from the use of the ion pairing reagent. To introduce, plasma-free medinefrin and non-medinefrin, or PMEDs, are the best biomarkers to diagnosing pheochromocytoma, which is the tumor in the adrenal glands. In the past, the analysis of PMEDs has been done with GCMS, immunoassay, and the radioactive immunoassay. All those methods have their shortcomings, and recently, LC-MS has become the preferred technology to analyze PMEDs because of its high sensitivity and specificity, and also the very fast and simple sample preparation. In this poster, we report a method for PMEDs quantitation using the novel ion pairing solid phase extraction, and also use the porous graphitic carbon column for the LC separation. Figure 1 is the molecular structures of these two molecules. As you can see, they are very small and appear to be very polar, which makes the sample preparation very challenging. In the methods, we have this ion pair solid phase extraction, and we start from 500 microliter of plasma sample, and we use the HyperSep C18 solid phase extraction cartridge. The first step is to precondition the cartridge with 0.1% PFHA or perfluoro heptanoic acid. We load the sample after the preconditioning, and we wash the column with also 0.1% PFHA. The purpose of this step is to wash away the other hydrophilic interferences such as salt or other compounds, which doesn't form the complex with the PFHA and to increase the hydrophobicity. So with that step, we retain the PMEDs complex with the PFHA on the C18 cartridge, and then we use the 60% organic solvent to elute these two compounds. We dry down the eluate and we reconstitute with 2% formic acid and do the LC-MS. In Table 1 and Table 2, you can see the LC gradient details and also the source parameters and SRM transitions. Validation of the method has several parts. We start from the calibration curve by generating the curves in the charcoal strip serum. We also determine the accuracy and the precision of the method by using two levels of the control samples spiked with different concentrations of medinefrin and the non-medinefrin. We also check the recovery of the sample preparation and ion suppression, and also the linearity of this method. The results. First, the calibration curves for both medinefrin and non-medinefrin looks excellent. We have a very good R-square value for both medinefrin and non-medinefrin. They are both above 0.99, and the difference between the measured concentration and the specified concentration is very, very low for all the 5 calibrators. The extraction efficiency for the SPE step was determined by spike the medinefrins and non-medinefrins, and also their internal standards before and after the SPE step. And we have determined that the absolute recovery for these compounds ranged from 86% to 98%, and the relative recovery against the internal standards are almost 100%. We checked ion suppression by these post-column infusion experiments. We have seen that there's no obvious ion suppression during the elution time where medinefrin and the non-medinefrin are eluted. We checked the linearity of the method, and we have determined that for medinefrin, the linear range is between 7.2 picogram per ml to 486.8 picogram per ml. And for norepinephrine, it's 18 picogram per ml to 989.1 picogram per ml. And also within this range, the accuracy ranged from 92% to 118% for norepinephrine and from 92% to 115% for norepinephrine. The determined LLOQ for the two compounds, norepinephrine and norepinephrine, are 7.2 picogram per ml and 18 picogram per ml. Precision of the method was first assessed by the spiked charcoal strip serum at two concentration levels. We have calculated the inter-assay and the intra-assay CV values, and they are between 2.1% to 10.9%. Precision was first assessed by charcoal strip serum, spiked with two concentration levels of norepinephrine and norepinephrine, and the CV are between 2.1% and 10.9%. And also, the precision was also assessed in the human plasma pool at 36 picogram per ml and 53 picogram per ml for norepinephrine and norepinephrine. And the CV, intra-assay CV, is only 6.3% and 7.8%. So basically, we have really excellent precision for this method. We also checked the interference for the norepinephrine and norepinephrine. And one of the compound, which is epinephrine, is a catecholamine. It has the same molecular weight as norepinephrine. So we want to determine whether it can contribute to the signal from the norepinephrine. From the chromatography, we can see that epinephrine and norepinephrine, they are basically resolved by this hypercarb chromatography. So that is not a worry for this method. In conclusion, we have developed and validated a very robust and sensitive ASMS method for PMAS quantitation. We use the ion pair reagent as the SPE procedure, and we also use the hypercup column for the LC separation. The following performance characteristics was validated. We have the norepinephrine linear from 7 picogram per ml to almost 500 picogram per ml with very good accuracy. We have norepinephrine linear from 18 picogram per ml to 989 picogram per ml with also very good accuracy. The intra and inter-assay CV ranged from 2% to 11%. We have no ion suppression, no carryover, and we did not observe any adverse impact on the mass spec from the use of the ion pairing reagent. Thank you for watching the presentation. For more details of the method, please go to thermoscientific.com, keyword search plasma metanephrines. You can also go to ASMS official website to get the abstract and the poster.